Alright, this is just a little video to help you out specifically with this Saturday's launch and just balloon tracking and prediction in general. As you see here, I have two paths. They look pretty similar, and I wanted to talk to you about the differences. Um, I think this could be helpful for people who are on the road and chasing, so you know what to expect. Uh, and the general principles here can apply to any balloon launch, but this specific image may specifically apply to this Saturday's balloon launch. What you see here, why these are different, is these are two different ascent rates. Um, it's a little bit hard sometimes when you first think about balloon flights like ours to get it in your mind how it's flying and why it's changing directions, um, especially if you see one of my predictions and then you see an actual flight, uh, why it's changed a little bit. Um, these are what happens here is when you see a turn like there, um, what you have to keep in mind is this isn't just a straight line like a flat two-dimensional line like you driving down a road. Um, as time goes on, this is changing altitude as well. So, for example, that turn to the left happens at a specific altitude. I don't know what that altitude is right now, but for the sake of this video and this demonstration, let's say that left-hand turn starts at 30,000 feet. Um, you have the red line and the blue line. The blue line is actually a slower ascent rate. See, we land farther away with the blue line. So what happens is that left-hand turn starts at 30,000 feet. If it takes us longer to get to 30,000 feet, we travel further. In this case, further sort of northwest. So that's why, if you look at these, you know, if one of these was a prediction for the day and one of them was the actual flight for the day, they're actually pretty similar. Like, I know a lot of people might look at that and say, well, we're several miles off, or we didn't turn where we were supposed to turn. We were supposed to turn around Bremen, and we turned northwest of Bremen instead, but really it's about the same flight. You just have to think about what the changes in ascent rate speed do to a flight. So, yeah, if it happens, if a turn or some specific shape that you're looking for in a flight path happens later, that means we're going slower, we're ascending slower than that prediction. If it happens sooner, let's say the blue was the prediction and the red was the actual flight path that we got on that day, we turned sooner, so we're ascending faster. And in this case, the blue is 800 feet per minute ascent rate, and the red is 1,000 feet per minute ascent rate. There are still some dynamics to this to flights that you can't completely predict. We can roughly talk about the burst altitude and what it would be based on the balloon size and how much helium we put in it, and therefore the ascent rate that we get. But fine-tuning that exactly is basically impossible because it comes down to the manufacturing of that specific balloon. If you launch two 1,200 gram balloons at the same time with the same payload and weight and the same amount of helium, there would be differences in their burst altitudes just because in manufacturing one was slightly weaker than the other. So there will be still some adjustment on the fly while we chase. Even if we, for example, specifically nailed it down and got the 800 feet per minute ascent rate that we want, we may not land where the 800 feet per minute prediction says because we may burst sooner or later than the prediction. And also, I'm still doing a little bit of research, and by research I mean actual flight data with the parachute that we have and the payload. So I think I've nailed it down pretty good, and small differences in the descent rate under the parachute are they have very minimal effect on the landing site. The other thing that can complicate the descent is how much balloon you bring back. When we burst, there's still the neck of the balloon tied to the top of the parachute, and it still brings balloon fragments with it. For some reason, we didn't bring back much balloon at all on the last flight. On previous flights, we've brought back so much that I can have like 2 hands full of weather balloon fragments. So you have the weight of that comes down with it too. And sometimes the line that's attached to the balloon can strangle the parachute, which we actually had happen a little bit on this last one, in July. Fortunately, it didn't strangle it to the point where it rendered the parachute useless, but it did slightly increase the descent speed. But we have room for error there where it would still be safe, but that will affect how soon it lands, how short of a prediction it lands. So those are just some of the factors in a balloon launch that you have to keep in mind.